Good evening, cadets. I am A.O. Shaw, and I'll be your instructor for today's lesson. Gradient. What is a gradient? Gradient is the measurement of a steepness of a slope. What I like to say, it's the measurement of a point of elevation. There are many reasons why you want to find a gradient. Usually, it involves the map, but you might need to find the gradient of a slope in real life. For the most part, especially in the field, you'll be trying to find a gradient on the map, specifically the topographical map. And to find a gradient is very easy. It involves a formula, and the formula is vertical interval divided by the horizontal equivalent. That's the technical terms. To simplify it, it's height over distance, or what you may have heard before, rise over run. How you find the vertical interval is you're going to identify point A and point B. So you will be given points using the 4-point and 6-point grid reference. Once you identify point A and point B using the 4-point or 6-point grid reference, you identify the nearest contour to point A and the nearest contour to point B. So what are contours? These are thin lines that represent points of equal height above sea level. And here is an example of a contour. These are all contours. Contour, contour, contours, contours. And of course, these are invisible lines. They're only on the map, not in real life. And you can find the contour, the information for contour, in the marginal information as a conventional sign or symbol. And so here it is on this map. As you can see, contour, it's in the marginal information, specifically the conventional sign and symbol. Now, this information here is important, and we'll get to it later. This is 20 meters, VI, vertical interval, up to 80 meters, 40 meters VI, thereafter. So, you've found point A and point B. You've identified the nearest contour to point A and point B. The next step is to subtract the smaller contour from the larger contour. Once you've done that, then you find the distance by range between point A and point B, and that will be your horizontal equivalent. Your answer will result in a fraction. So you'll be getting a fraction as your solution. This fraction should be in the smallest possible fraction it can be. So if your answer for the gradient ends up being 5/10, the smallest possible fraction of 5/10 is a half. And that is going to be your final answer for the gradient. Let's say you're given, for the purposes of examination, you're given a range of gradients and asked to evaluate which one of these gradients or which one of these slopes is the steepest and which one is the most gradual. A trick to do this, in fact, is to look at the denominator of the gradient, and the larger the denominator, the steeper the slope. The smaller the denominator, the more gradual the slope. That's a trick to learn it. Good evening again, cadets. I said something that I realized can easily be misinterpreted. So I said the larger the value of the denominator, the steeper the slope. The smaller the value of the denominator, the more gradual the slope. That is correct, indeed correct. However, it is only correct if you factor in how fractions work. the larger the value of the denominator, the smaller the fraction, and the smaller the value of the denominator, the larger the fraction. So that's how that will work. However, as I did not tell you that it only applies when really you're thinking of how fractions work, it can easily be misinterpreted. You can easily think that, okay, 1 over 15, a fraction of 1 over 15, you're looking at the denominator, okay, this is actually the steep or the slope, as opposed to 1 over 4, you're looking at the value of the denominator, it's number 4, you're saying, okay, this is the more gradual slope. So forget about that and just know this. The larger the value of the gradient, the steeper the slope. And so looking at the denominator, the larger the number, the larger the value of the number, the larger the number, the more gradual the slope. The smaller the number, the steeper the slope. That's it. There are ways to evaluate gradients in real life, and there are reasons why you might want to evaluate a gradient in real life. For example, you are planning an assault. You're going to assault this point of elevation, and your team is at the base. You're trying to mount an assault. Knowing the gradient of the slope will be very helpful. Let's say you want to establish a base of operations at a point of elevation that is advantage to you. For whatever reason, you might want to find out. One of the reasons you want to evaluate the gradient of a slope, in real life, it's pretty straightforward as well. But you'll need to know some information. It requires two pieces of information, in fact. It requires measuring distance, judging distance, which is something you should already know, as well as the information on contours. So this information that I showed earlier, you should margin that information for contours where it says 20 meters VI up to 80 meters, 40 meters VI thereafter. That information is very important. So that means every 20 meters, it increases by 20. After 40 meters, it starts to increase by 80. And that helps you determine the steepness of a slope. It helps you determine the gradient. So when you apply judging distance, you're looking up the point of elevation. You're judging distance, you know what 40 meters look like. You're saying, okay, this looks like around 340 meters. So you're saying this is around a 100-meter point of elevation. So you're expecting a gradual slope as opposed to a steep slope. If you're looking at a point of elevation now and you say, okay, I know 40 meters look like this, looks like 1,000 meters. Then you know that after you pass 80 meters, it's going to get steep, and you can plan whatever your mission is from there, or whatever the reason why you want to evaluate the slope in the first place.